what we're going to look at is how to draw what are called Lewis structures. So molecular compounds are made up of individual molecules that have a certain three-dimensional geometric structure. What a Lewis structure is, it's a two-dimensional representation of the molecule. We'll use these two-dimensional representations to figure out the three-dimensional structure the molecule takes, and we'll also use them to classify the polarity of molecules as well. When you're looking at a Lewis structure, a single line represents a single covalent bond that is two electrons being shared back and forth between those elements. Two dots placed together is a non-bonding pair. It represents electrons that aren't being involved in the formation of a chemical bond. When you're drawing a Lewis structure, there's certain steps that you're always going to follow. We're going to start looking at how to draw basic Lewis structures today. So I'm going to walk you through the first 6 steps that no matter what Lewis structure you're drawing, you're always going to follow these things. The first key step is you need to create an inventory to figure out how many valence electrons the molecule has. So for PCl3, there's phosphorus, there's chlorine, there's 1 phosphorus. Each phosphorus contributes 5 valence electrons. It's part of group 15 on the periodic table. There's 3 chlorines. Each chlorine contributes 7 valence electrons. I multiply it across, then add, and I have a total of 26. This first step is key because if your valence electrons are incorrect, the rest of the steps will not make sense. All of the ones I'm asking you to solve should be even. So 26 valence electrons is an even number. If it was odd, I knew something was wrong and I would go back and check my inventory a second time. Now you need to figure out what the central atom is. It's going to be the first element in the formula. The only exception, hydrogen can't be the central atom. So if hydrogen's the first thing, the second element in line is going to be the central atom. So for PCl3, phosphorus is placed in the center. Now I need to connect the outer elements to the central one. There's 3 chlorines, so 1, 2, 3, and I'm going to connect each outer element to the central one using that single covalent bond that uses up 2 electrons. So 1, 2, 3, I used up 6 of my electrons, so I'm going to subtract from my inventory. It's really important to keep track when you're adding electrons into your Lewis structure that you're subtracting from your inventory because you need to know when you reach 0. My next step is I need to fill the shells of the outer elements. So what I'm going to do is I have 3 chlorines. Each of those chlorines needs to have its outer shell completely filled. It needs 8 electrons on it. Each of those chlorines already has 2 electrons because of that single covalent bond. So I need to add 3 non-bonding pairs to each one. The key thing to kind of understand is you're not doing a dot structure where you have to go clockwise, counterclockwise. You need to just place 3 non-bonding pairs on each of the outer ones. So it doesn't matter which chlorine I start at, but let's say I do 1, 2, 3 non-bonding pairs. That uses up 6 electrons. I now have 14. 1, 2, 3. I now have 8. 1, 2, 3. I now have 2 left over. You should never run out of electrons when you need to fill the outer shells. So now I have 2 electrons left over. My next step says place any remaining electrons as non-bonding pairs on the central atom. So I have 2 electrons. I'm going to place them in a pair on that central atom. And now I've reached my 0 mark. So just make sure when you're adding non-bonding pairs on that central atom, you're giving them their own real estate, their own space away from any bonding pairs. So now I want to check my central atom, and I want to see how many valence electrons are on it. That phosphorus has 2, 4, 6, 8 total valence electrons. Therefore, it's following the octet rule. Therefore, there's nothing else that needs to be done. This molecule, this Lewis structure is finished. In terms of bonding and non-bonding pairs, there's 3 bonding pairs and 10 non-bonding pairs. 10 plus 3 gives me 13. Multiply that by 2, that gives me 26. That matches how many valence electrons were supposed to be in the structure. That's another key thing to check for. Make sure that your inventory matches how many valence electrons you end up having in the final Lewis structure. All right, next example is NH3. So I'm going through and doing that inventory. And what I figure out is that there's 8 valence electrons total. I'm going to place nitrogen in the center. It's the first thing in the formula. That's generally going to be the central atom. I place the hydrogens around it, and I'm connecting each of those outer elements to the central one using those single bonds that use up 2 electrons each. So 2, 4, 6, I used up 6 of my electrons, and I have 2 left over. Why I included this as an example is hydrogen is something that you need to be really careful with when drawing a Lewis structure. It's an exception where it doesn't want to have 8 valence electrons to be stable. It wants to have 2 instead. So as soon as you form a single bond with hydrogen, it doesn't want anything else added to it. So my next step would be to fill the shells of the outer elements, but since all of those hydrogens are already happy, they all have 2 valence electrons, I can skip that step and then I move on to the next one. So be very careful with hydrogens. You never add dots to them. You never make double bonds, triple bonds with them. Once a hydrogen has a single bond, it's done, it's happy. Don't add anything else to it. So I'm going to place those 2 remaining electrons on nitrogen on that central atom, and now I've reached 0. I'm checking my central atom. Nitrogen has 2, 4, 6, 8 valence electrons around it. It's following the octet rule. It's happy. I stop. Nothing else needs to be done. There's 3 bonding pairs, 1 non-bonding pair. 3 plus 1 gives me 4, times 2 gives me 8. It matches how many valence electrons were supposed to be in the Lewis structure. Always check your work. All right, so the next thing that we need to look at is sometimes you're going to be asked to draw a Lewis structure of a polyatomic ion. If you're drawing the Lewis structure of a polyatomic ion, there's just 2 key things that you need to kind of pay attention to. The first is you have to factor the charge into your valence electron inventory. The second thing that you need to do is you need to place the final correct Lewis structure in brackets with the charge in the upper right-hand corner. So in terms of dealing with the inventory for a polyatomic ion, you're doing exactly what we did in the past 2 examples. The only difference is you're going to take that inventory and do the opposite of whatever the charge is to get the final number. So for ClO2 -1, I would go through and do my normal inventory and get 19, but then I would add 1 to it for it to be 20. For H3O +1, I would go through my normal steps to get 9, but then I'm going to do the opposite of the charge. So I subtract 1 to get a total of 8. So if you're given a polyatomic ion and asked to solve for its Lewis structure, do the normal inventory, but then take that number and then do the opposite of the charge to get the final number. So what I want you to do is let's kind of look at SO4 -2. So I'm going to go through and do my inventory. I would get 30, but I have to be careful. I have to add 2 to it in order to factor in that charge. I'm doing the opposite of what the charge is, so +2 to get a total of 32. Sulfur is placed in the center, 4 oxygens around it. I'm connecting each oxygen to that central atom. That uses up 2, 4, 6, 8 valence electrons total, and now I have 24. I'm going to start to fill the shells of the outer elements. I pick an oxygen, it doesn't matter which one, and for each oxygen I'm adding 3 non-bonding pairs, 1, 2, 3. As I'm adding, I'm subtracting from my inventory. That's, like I said, a key thing. Either actually write it down on your sheet of paper or do it in the calculator, because you have to know when you reach 0. So you can see at this point I filled that last one and I reached 0. I have no remaining electrons to place on the central atom, so now I can go through and check that central atom. Sulfur has 2, 4, 6, 8, 8 valence electrons. It's following that octet rule, so this Lewis structure is done. I just need to remember to put the brackets around it. The charge is -2, so I write -2 in that upper corner. There's 4 bonding pairs, 12 non-bonding pairs. That's 12 plus 4 gives me 16 times 2 gives me 32, which matches what I was initially supposed to place in the structure. All right, next one is H3O plus 1. I go through and I do my inventory and I get a total of 8. So I made sure to factor in that charge, 9 minus 1 to give me 8. This is a good example because I have H3O plus 1. Hydrogen cannot be the central atom. Oxygen is the next thing in line, so oxygen is going to be treated as the central atom. I'm putting the 3 hydrogens around it, connecting each one to the central one with a single bond. That's 2, 4, 6. I used up 6 electrons, so now I have 2 left over at this point. I cannot fill the shells of those outer elements because they're hydrogen. They have that single bond. They're happy, they're stable. They don't want anything else added to it. So since I can't place anything else on those hydrogens, I go to my next step. I'm placing any remaining electrons as non-bonding pairs on the central atom. I have 2 electrons left over. I'm placing them on that central atom, and now I have 0 left over at this point. I'm checking my central atom oxygen, 2, 4, 6, 8. It's following the octet rule. It's happy. I just need to put the brackets around it with that plus sign, and then it's done. Bonding pairs is 3. Non-bonding pairs is 1. 3 plus 1 gives me 4 times 2 gives me 8. It matches how many valence electrons I was initially supposed to place in the Lewis structure.